Yelua, reduce that volume, please. Five minutes, my job, but I didn't see it. Yelua, you are distracting me though. So this screen.
Bad Mutiri.
Okay, now. Only more total perimeter.
Okay.
What I did is, if you look at the, can you see the drawing?
Yeah, money drawing MB.
Okay, so the drawing up, must share.
No, me drawing you.
Let me first share the drawing. Only take a snapshot there.
Should be drawing to the video, Yanni.
Mo fẹ́ share or not, so that you will see it lively better, Abi. Okay, the length of the building is 14.45. Can you see it now?
Yeah, Mutiri.
And why the breadth is 13.45. Then on the drawing, we also have some features, like is a proposed control building. So we have a feature for a void. Maybe they want to fix in one equipment that will go down to the foundation. Maybe that may be the reason for this void. There are some other void also, like this one that is 1 meter by 450 mm. Then the thickness of the slab is 150 mm thick. So
sorry, educate me. The pocket, what is it for?
Pocket also is just like a opening, maybe a little openings of 450, or they normally put pockets. Let's say where they want to put a particular equipment. Okay, can you remember the conventional grinding machine? Lister generator. To come, you know, if you don't see, you know, you man ṣe sórí floor in the building, you want call it fun. So yeah. So just vision something like that. So I put on my like fix sórí floor.
Okay, then I'm lost in the foundation straight.
Yes. So that may be need for it to go down to the foundation. So if you don't make provision for the void at the onset when you are doing the construction, it implies that you will have to cut out some area. So it's better at the onset you make the provision for the void. You don't cast the entire floor area, so that the equipment can sit in. So that is the essence of the void.
Okay.
I hope that is clear now.
Yeah.
So now let's look at the perimeter. Perimeter is what I call GAT here. So the length
Okay.
is 14.45. You know we have two sides. It's a rectangular shape building. So two of them will give you 28.9 in running meter since we are dealing with GAT now. Then the breadth also is 13.45. We have two of them also, which is 26.90. Now, if you look at horizontally, I tag. So if you look at that building, you know, there's a length, there's a dimension that is parallel to the length, which is also the same length of 14.45. That is the one I call horizontally. So because if you position your drawing on X and Y axis, you see that the one that is parallel to where you have your length will also be your horizontal internal wall. While the vertical one, the small one, the internal wall of 1.15, I think I have about over there. So that will give you the overall running meter, the overall length of your perimeter. Then we know at every junction, at the externally, where the length and breadth are meeting externally, there is a junction. I hope you can see my drawing now.
Yeah, I can see it.
This junction.
Okay.
And this junction.
Okay.
But the width of our foundation is 675.
Yeah.
The internal wall is 225. So to this side, you have 225. To this side, you have 225.
Yeah.
Those are the junction I was talking about there.
Okay.
For your guard.
And that internal wall.
Yes.
Is this supposed to be 14.45?
This?
That one you called horizontally.
Okay.
Is it supposed to be 14.45 also?
It depends on the approach you are using. You can remove to make it internal. You can actually remove your 225 now.
225. Yeah,
You can
225
remove
times
it
2.
now. But at the same time, you can leave it and remove it when you are doing your volume.
Okay.
So it depends on, I just calculate the GAT overall for now. But you can also remove it later on. And that is why I have deduction here. Internal, I have 6. You can see when you get to excavation.
Okay.
Externally, I have 4. You can see I have deduction.
Okay. So now this excavation work.
Yes.
Is it do you combine it with the topsoil excavation or
no?
We have to do topsoil excavation separately?
This is pit excavation, your trench. This is trench because you look at the data that I use the GAT. Can you see? I use the GAT. I use the width of the foundation, which is 675.
Yeah.
Then I use the depth of the foundation, which I show here. You can see the width is 675 and the height is 900.
Yeah.
Then there's 50 mm blinding.
Okay.
Which make this 950.
Okay.
So that is for, can you see the measurement sheet?
Yeah, I can see it.
Okay. So that is for trench. So then I now made deduction for all the things that I'm supposed to remove before. Like that horizontal internal wall that that I took in excess before. I made deduction for them. So the implication of this is I have my guards, and you know, virtually everything that you are going to do in a building, you are going to use your perimeter.
Yeah.
Which is your guard. So it's a matter of just utilize the data. Now, when it comes to leveling and compacting, I have my guards. I have my width of foundation, which is 675.
Yeah.
You can see this approach, it will make your work to be faster.
Okay.
It makes your approach just a way of linking. You just link your guard and your width to everything you are doing. Do you get? So the same thing when I get to blinding. The only thing is your unit of measurement will now be different. Unlike under leveling and compacting. Unlike leveling and compacting, that is square meter. Under your PCC, you resort back to volume, just as you have in your excavation.
For blinding?
Yes. For your blinding, your blinding is your PCC, is concrete work.
Okay.
It's volume. What you are doing in volume is you are displaying a space. The space you are displaying now is the excavated space you have already excavated. You are displaying it with concrete, which is mass concrete. The thickness of that concrete is 50 mm, which is this. While the area, the length, is going to run along all the wall, both the internal and external wall. That is why we are using our guards. And it's going to be between the faces of the excavation. That is why we are using our width of 675. Is it clear now?
Okay.
So
yeah, because I think the way I think school work is kind of different from real life work.
That is another thing entirely. School work is,
I think they told us that time that if your concrete is less than, I think 100 mm or something, it should be in square meter, not cubic meter.
What?
But now in this case, we have 50 mm as the concrete.
Well, that is based on maybe standard measurement, maybe BESMM. When you check the latest, when we see the latest, we'll be able to say if that is still correct. But I don't think it's possible again now, because when you want to build up quantity for your concrete, you are dealing with volume. So each of the material will come in volume. Though you can also convert it to square meter, by the way. So if you build up your rate in cubic meter, it's just a matter of multiplying it by your thickness. Do you get? So just the format they want it to be. But generally acceptable throughout the whole world, concrete is always in volume.
Yeah, in cubic meter,
excavation.
Yeah.
So that is you can look for, you can check your BESMM to know the latest measurement law about that. But I believe your concrete should be in volume. And if you want to move from volume to square meter, just a matter of multiplying by your thickness, whatever, or the depth you are dealing with. So I believe. So today, as a point of because our section will soon end. So this guard, I want you to, maybe you have to do your own in Excel also, so that I'll be able to see what you did. Then excavation quantity, leveling and compacting, blinding work. Then RCC. This RCC is the one we have above the blinding, above your PCC, which is 225 here.
What is RCC mean? More don't just
RCC is reinforced concrete.
Okay.
1:2:4. The other one is the other one is PCC. Blending is PCC.
Plain concrete.
RCC. We are going to have RCC. We call it concrete foot.
Yeah.
Your concrete foot is going to be on your PCC, on your blinding. The only one is reinforced. The the capacity of that concrete, the tensile strength that it can withstand is much more than the other one, which is normal mass concrete. That is just the difference. Okay. And if you want to put steel, we are going to use RCC, reinforced concrete, because you will reinforce with it iron. But the other one is just a mass concrete, which the mix ratio may not be that serious than unlike RCC. They are both different form of concrete, but one is more expensive, one is more cement concentrated than the other one. They use PCC just for the job, so that before you, instead of putting your reinforcement on the bare soil, you put PCC, so that, because in the soil there's a likely tendency of movement of moisture from the ground. But if you the PCC, it will contain concrete. It will contain little cement. So the water will not be able to percolate and touch the iron, so that it will not rust. So that is why most people use PCC before you put your RCC, instead of putting your reinforcement on the ground, on the bare ground. So they are both concrete, but the cost indication as a QS is different. RCC is more expensive. It can be, the mix ratio can be starting from 1:2:4. Some also use 1:36. If maybe a grey slab, I mean a German floor, that may not necessarily need much pure concrete. Or your PCC, your PCC will be less than 138. Though some people also use 138. It can be 148. It can be some other mixture that is much more not serious like normal RCC concrete. So that is that. So what we will do now, depending where we are going to meet next, I would like to see your workup on Excel like this. Whichever approach, you can go by the approach of instead of using 14.45 for internal wall, horizontal internal wall that I use. Let's use your own. Deduct your 225 to the two side, and see what you are going to have. Take off for excavation, leveling and compacting, blinding work, RCC.
I've done. I'm with you. I did topsoil excavation and
topsoil. Topsoil. If you want to do topsoil, you know, the reason why I don't bother to do topsoil is the actual building size is about 14.5 by 13.45. But if you want to do topsoil, there may be need for you to have a site survey. Do you get? The site may be larger than this. Do you get? Assuming that I gave you a site layout of, it may not be only this building that we have on that site, number one. Number two, you may want to clear more than this entire area. But let's say you want to assume that what we have on the site is only this 14.45 by 13.45. So your topsoil, what will be your topsoil?
Like 150 mm.
The thickness of the topsoil is going to be 150 mm. But what will be your quantity?
That would be like the length and the breadth. That's meter square.
But you know, you have to put some extra, because your actual working area, you can't just use your actual.
I will add the spread like 225.
No, just call it extension. Don't call it spread again. We are no more in school. Just say extension. There can be extension of 600 here, 600 here, 600 here, like 2 foot. You know, a foot is 0.3. So like 2 feet extra in both sides. So the length 600 in one side, at one corner 600, at the other corner 600. That will make it 1.2 to the length. Then to your breadth 600. That will make it 1.2 to your breadth also. Then you know you are going to get your quantity in square meter. Now that area that that you got in square meter, you need to dispose it offsite, because the essence of the topsoil is for you to remove the vegetable soil that is not good for construction. So what will be your volume for disposal? What will be your volume now? How will you get your
That will be the length and breadth with the depth of the topsoil excavation, which is 0.15.
Okay, that is it. Then when it gets to your description, you now made mention of, is it offsite? Are you disposing offsite? Are you disposing in a heat on
No,
site?
I think it depends on the. No, we are going to leave it on site.
Okay.
For the main time, because we are going to reinstate some when we are doing backfilling and.
Okay, well, you may not need it for backfilling, but should in case you have a external work in your building, in the project, you can actually use that excavated topsoil for green area. Do you get it? Otherwise, you don't need it on site again. You have to dispose it off. But if you want to have green area, you get.
I understand.
Green area, you have to use it.
Okay. So, if you want to like do some vegetation, you have a plant or something.
Yes.
Okay. Yes. So this trench excavation, your facility in site.
Trench excavation. Trench excavation, because you're actually going down inside the pit. So that one can be reused for filling.
Yeah.
That can be reused for filling. But your topsoil, because the reason why you are excavating is not suitable for construction. That's why you are cutting it away. So so you have to cut it away if you don't have any green area to do. So what we will do for me now, against our next meeting, will be, you will take off on Excel. If it was just here, you will read now. So take it off Excel like this. Do your quantity up to backfilling. Do your quantity up to backfilling. I think that should be all. Then from that, next assignment is on preliminary cost for that renovation bill. So choose one PC sum there. Do you get any PC sum that you are comfortable with? You know, in that bill that I sent to you, there are so many provisional sum. The reason why they use provisional sum is maybe because of time. There is no enough time for them to collate all the information that will go into that particular activities. So you put provisional sum, which will be subject to the measurement later. So pick any one that you are comfortable with. Then we are going to analyze it together. By analyzing, I mean the quantity that will go into that particular provisional sum and the cost implication for those quantity. For that quantity, the activity that will build up into that quantity. Yes. So that is 2 assignments. One is for you to take off up to backfilling quantity. Then the other one, your preliminary, your provisional quantity, provisional sum, any one that you are going to use.
Sir.
All right, take care.
Yes,